Okay, this is stoichiometry test review questions 10 through 12. So we're here with period 6 going over these. We're working on questions 10 through 12, which is using this equation of 3 coppers are reacting with 3 nitric acids, and somebody came up, it did say in the problem, it asked you about nitric acid. Okay, 3 nitric acids, and they change into 3 copper nitrates plus 2 NOs, copper monoxide, nitrogen monoxide, plus 4 waters. So to begin with, number 2, calculate the number of moles of water produced when 6 moles of copper nitrate are formed. Now this is a mole-mole problem. It's going to be just one step. So let's take a look at this. So I'm going to call what I'm given going to be mole A, and in this problem, see mole A. We're looking for, we're given moles of copper nitrate. So I'm going to just call this one copper nitrate. So what's given? Copper nitrate. And we're given 6 moles. So we're starting up here at moles. And we're going to, in this problem, we want to find out how many moles of water are produced in this reaction. So I'm going to say that moles of B are H2O. Oh, sorry. So we're going to be starting here with moles of copper nitrate. In fact, in this problem, how many moles do we have given in the problem? Hello, a little help out there? We're given 6 moles. And then, so let's get this set up. Number 10, we're given 6 moles of copper nitrate. 6.0 mole of CuNO3, 2. And I know it's a pain to do that, but do it, and you won't make a mistake unless you can't do simple division. So at this point, we just need the molar mass. The molar ratios. So the molar ratios, we want to go mole B, which in this case, it's going to be moles of H2O over moles of mole A, which this one is Cu and a copper nitrate. So how many moles of water do we have in our balanced equation?
4.
Okay, so we have 4 moles of H2O. And how many moles of copper nitrate do we have in the balanced equation? How many? It's copper nitrate. We're not doing nitric acid. So whoever said 8, no, it's copper nitrate. That's what we're working with. We want to get rid of this. So how many moles of copper nitrate? 3 moles of CuNO3, 2. And let's see. What else do we need? We're done. Because we just need to go from moles to mole. Now the fun part. I'm going to use an aqua pen today. Okay, so we're going to cancel moles of copper nitrate with moles of copper nitrate. And we can reduce here. 3 goes into 3 one time. How many times will 3 go into 6? 2. Whoosh, whoosh. Okay, now, what is 2 times 4?
8.
So the answer is going to be 8 moles of H2O. How many people got that? Got that one okay? Cool. Excellent. Now we're working on number 11. Number 11, working with the same equation, but we're just got a different question now. How many grams of copper would be needed to react with 4 moles of HNO3? Well, let me see. I'm given HNO3, so I'm going to call this side of my triangle HNO3. HNO3, which is nitric acid. And we got to convert it into moles of plain old copper, so I'm going to call moles of B on this problem Cu. And we're given 4 moles of HNO3, which is nitric acid. So we're going to start over here with 4 moles of nitric acid. And then we're going to convert it into moles of copper. And then I believe the question wants us to find grams. So we've got a 2-step conversion, mole-mole ratio to get us to moles of copper. Then we got to convert it into grams. So we are given 4.0 moles of HNO3. Am I okay so far? You see it up there okay?
Yeah.
Haven't made a mistake? Now we got moles. We need to set up the molar ratio. So we need moles of copper over moles of HNO3. How many moles of copper do we have in our balanced equation?
3.
We've got 3 moles. Wait, I heard one person. Is he correct?
Yes.
Come on, wave at the person bringing the stuff. Hi, Tyler. Okay, go. Now, 3 moles of Cu. Is that correct? How many moles of copper nitrate do we have in the balanced equation? Got 8? 8 moles of copper. Oh, excuse me. Of HNO3. We can cross off moles of HNO3 with moles of HNO3. Let's reduce. What can we reduce 4 and 8 to? Have I made a mistake yet, anybody? Is this what you've got? Okay, cool. Hey, I'm not going to do your work for you. What do I make this? 1. What do I make 8 then? 2. So now is this problem going to come down to being... Oh, wait, we're not done yet, though, are we? Oh, see, I almost made a mistake. Okay, cool, because we want grams. So, okay, we're not quite ready to do the equal. Got my pen too quick. So now we need to convert this into back from moles down to grams, and we do that by taking the molar mass. So let's see, 1 mole of Cu is how many grams? Agree with that. Copper is 63.5. We round that to 64. So 64 grams of Cu. Now we can cross off moles of Cu with moles of Cu. And let's see. Now do we just have 3 times 64? Oh, we got the 2 here, don't we, from before? Oh, great call. Who said that? Right. Look at the lights on over there. Okay, so now we had this 2 from before. That becomes 1. What's half of 64? Come on, it's $64, 64 grams, 32. So now we've got 3 times 32. Is that correct? Divided by 1 times 1. What's 3 times 32? 96. We can all agree on that? 96, and it's grams of Cu. Okay. And lastly, number 12. How many people, this one kind of was like, oh my gosh, how do I do that? Don't let it freak you out. We've done these before. So in this one, atoms of copper. Now look at on my chart here, I've already got copper over here. I'm just going to leave copper over as molecule B. And we're changing this into molecules of NO. Is that correct? We're going to NO this time. So I'm going to erase what I had before. This will be NO. So what we're given in this problem is 36 atoms of copper. So we're going to start over here. We're given 36 atoms of copper. Okay. And then we need to convert that into molecules of NO. And molecules of NO are going to end up being right over here. Let me get rid of the distracting stuff from the previous problem. So we're going to convert to moles. Mole ratio over to here and then back down. So it's a molecule setup. What are we given in the problem? Come on, wake up out there. What are we given in this problem?
36 atoms.
Thank you. 36 atoms of Cu. And we need to convert that into moles. So let's see. Oh, for that we have Avogadro's number. 6.02 times 10 to the 23 atoms of Cu is what? Come on, what is it?
1 mole.
1 mole of what? Of Cu. Okay, atoms of copper will cancel out. And at this point, now we got moles of copper. Now we need to do our mole ratio. We're going over here to moles of NO. So how many moles of NO do we have in our balanced equation?
1.
Is this NO right? Who said 1?
Riley Deutsch said.
Okay, now here's NO. We have 2 moles of NO. You don't need a sister cat fight here, okay? 2 NO. Oh, that's moles, sorry. 2 moles of NO. And to how many moles of copper do we have in our balanced equation? 3 moles. 3 mole of Cu. I got to fix this. That's just driving me nuts. No, it's okay. I'm just mole of, that was Cu, was that right? No, that wasn't Cu. That was NO, wasn't it? Yeah, sorry. I'm just trying to straighten up, and I made it worse. Mole of NO. Okay. Now, moles of copper cancel. Moles of copper. Are we? Is this what the question's asking, or do we? No, we have one more. We're at moles of NO. Now we need to convert it into molecules by multiplying by Avogadro's number. Oh, let's try not to do it. 1 mole of NO is 6.02 times 10 to the 23, and so we're looking for molecules, M-O-L-E, molecules of NO. So we can cancel here and cancel there. We can cancel Avogadro's number here and there. Oh, I didn't use my colored pen to do that. Hold on. I like good. Okay. Oh, let's do how many times? Let's cross 3 with 36. How many times does 3 go into 36? Okay. How many times does 3 go into 3 to here? 1. How many times does 3 go into 6? 2. So we get 12. Oh, I hear a heavy sigh, so that means you're getting this. It's becoming easy. You're reaching summation. That's awesome. What is 12 times 2? 24. We don't have anything else up there. Divided by 1 times 1. Is it 24 molecules of NO? Is that what you got?
Yeah.
Let me see if that's right. Whoa, yeah, there we go. So, well done. Now I'm going to stop right here.